Have you ever wondered how a music app instantly knows who sang which song? Or how an online store can show you every product you've ever ordered? Well, it's not magic. It's all about connecting data. And today, we're going to pull back the curtain on the single most important tool that makes it all happen, the SQL join.
Okay, so picture this. It's a really common situation. You've got your data split into two separate tables. Over here, you have a nice clean list of artists, each with their own unique ID. And over on the other side, you've got a list of songs, each with its own ID and, this is the key part, the ID of the artist who made it.
The pieces are all there, but they're not talking to each other yet. So the big question is, how do we build that bridge between them? How do we take these two separate lists and create one single, meaningful view that tells the whole story? Well, this is exactly the puzzle that SQL joins were built to solve.
So here's our game plan. We're going to start with the most common type of join. Then we'll check out how to get a bigger, more complete picture with outer joins. We'll touch on a few specialty cases, and then we'll wrap up by seeing why this skill is, no joke, a data superpower.
First up is the real workhorse of the SQL world, the inner join. I always think of this one as the search for the perfect match.
The logic here is actually pretty simple. An inner join just looks for rows where a specific key, in our case, that artist ID, exists and perfectly matches in both tables. It's all about finding that confirmed shared connection between them.
This Venn diagram just nails the concept, right? Imagine all our artists are in that left circle, and all our songs are in the right one. The inner join only cares about that shaded area right in the middle, the data that exists in that shared space, nothing else.
And boom, here's what you get. A beautiful, clean, unified table where every single song is correctly paired up with its artist. You don't see any artists without songs, and you don't see any songs without artists. Only those confirmed, perfect matches made the cut.
But what if you need to see more than just the perfect matches? What if you wanted to find out which artists in your database don't have any songs listed yet? Well, for that, we need to move on to outer joins to get the full picture.
With a left join, we're basically picking a side. The rule is super straightforward. Keep everything from the left table, that's the first one you mention in your code, and then just bring in any matching records you can find from the right table.
And again, this visual just makes it so clear. See how the entire left circle, our artist table, is shaded along with that middle part? We're guaranteeing that every single artist makes it into our final result, whether they have a matching song or not.
Now, this result is incredibly useful. We can see all of our artists. For the ones with songs, the titles are listed right there. But for artists who don't have any songs in our database, we get this null value, which is just a fancy way of saying nothing here. And this immediately lets us ask totally new questions like, hey, which artists on our roster haven't released any tracks yet? So, what about a right join? Well, it's pretty much exactly what you'd guess. It's the mirror image of a left join. Instead of keeping everything from the left table, it keeps everything from the right table and brings in matches from the left. Same idea, just flipped.
Now, if you're the kind of person who wants to see absolutely everything and leave no data behind, you're going to want a full outer join. This one brings back everything from both tables, connecting them wherever it possibly can.
And this visual says it all. The entire area of both circles is shaded in. In our results, we'd get every artist and every song. That means we'd see artists with no song titles next to them, and we might even see some songs that are missing an artist name, maybe if they had a bad artist ID. You see the whole universe.
Okay, so beyond those main types, there are a few other specialty joins that are really useful in some very specific situations. Let's just take a quick peek at one of them.
The cross join is a bit of a wild card. It doesn't look for any matching key at all. Instead, it just creates every single possible combination. So if you have 10 artists and 100 songs, a cross join is going to give you 1,000 rows, pairing each artist with every single song. It can be powerful for generating test data, but you have to be super careful because it can create enormous tables and really slow things down.
All right, let's bring it all home. Look, understanding these different joins isn't just some boring technical exercise. It's a genuine data superpower. So the most important thing is knowing which tool to use for which job. And this little cheat sheet here is the perfect guide. Use inner for perfect matches, left or right to include everything from one side, and full outer to see the whole shebang. Seriously, just let those Venn diagrams be your mental guide.
And this is why it all matters. This is how you go beyond just looking at simple lists of data. It's how you uncover hidden relationships, it's how you combine customer information with purchase history, and it's how you answer complex business questions that are literally impossible to solve when your data is stuck in separate boxes.
You know, at the end of the day, that's what this is all about. SQL joins are the fundamental tool for weaving together all those separate threads of data into one single, coherent, and really insightful story.
So I'll just leave you with this question. Now that you understand how to connect the dots and build the bridges between your data, what incredible story is your data just waiting to tell?